Don't worry, I have not come here to stress you out, for I have come here to relax you. Hence the calming sounds and sensations of a stream of water rustling through the video to your wonderful ears. Okay, so I got a little ambient water music that I'm gonna play God a little bit and turn down the water. Let me play God for a little bit. There you go. You know that water? There it is. How about that? Oh, that's power. Control the water. So I made a video, actually my last video I made, which was how do you graph a straight line in slope-intercept form? Okay, that's what the video was about. That's okay. But of course, it stands to reason a lot of times, like the next thing you have to do is you have to graph an equation that's not already in slope-intercept form. And it's up to you to put it into slope-intercept form. So that's what I'm here to do today, is to relax you. Well, let me put the music back on. I don't want you to be stressed out. Hey, don't stress. Yeah, don't stress. Yeah, we got water. Don't stress. And so I'm going to show you how to put this in the slope-intercept form, and then we'll go ahead and graph it. So let's rock. Let's go get it. First thing you know is that standard form is pretty useful when what you're interested in is what happens when you add the x's and the y's. Like, that's pretty good. It equals 12. Like, that's interesting to me. This is interesting for other reasons. It does do a better job of conveying the slope in the y-intercept. So, let's first do some old school symbol manipulation, which means we're going to isolate this variable by doing the opposite. The opposite? Yeah, the opposite of everything kind of other than our variable. So right now we're adding 3x's, so I'm going to subtract 3x's. Now the beautiful thing about an equation is balance. And I just upset the balance, so I need to subtract 3x's from both sides. Because this gets me 0. So now I'm left with 4y is equal to 12 minus 3x. Because they're not like terms. And if they're not like terms, they don't combine. I don't know what the hell 12 minus 3x is, because I don't know what x is. You give me x, I'll tell you what 12 minus 3x is. So right now, that's it. It's just 12 minus 3x. Now, I like that, not me personally, but the slope-intercept form wants x first. So what we got to do here is we want to switch the spots of where they're at. Now we want to be careful, because 5 minus 3 is not the same as 3 minus 5. With subtraction, you can't just flip and get the same answer. You see, but you can with addition, right? With addition, it doesn't matter. 4 plus 3 is 3 plus 4. So what I recommend here is you just kind of represent this, instead of subtracting a positive, make it add a negative. Because that's all subtraction is. You can consider subtraction as adding the opposite, and then move them. So negative 3x plus 12. Lastly, we're going to divide by 4. More generally, we always divide by the number in front of y. And this gives me y is equal to negative 3/4 x plus 3. Holla back. That's how we roll. That's how we roll. All right. That's one way of doing it. Let's remember that equation. I'll show you one other method. This is a time where I always show two methods, because a lot of times I explain things and I just think to myself, well, this is how everybody explains it, so it doesn't feel like important. But this isn't how everybody explains it now. This is what I used to do when I was at the university, studying electrical engineering, rocking San Jose State and UC Santa Cruz. But what I would do is I would just kind of mentally like circle it and just move it over. Just like literally pick it up and put it over here. And you just got to remember when you do that, you got to change the sign. The sign changes. So if I want my 3x's over here, I got to make them negative. Cool? And then lastly, divide it out. Divide by 4, divide by 4. And we get y is equal to negative 3/4 x plus 3. So let's graph this thing. Let's see what we got here. We're going to start at 3. So, I mean, it's a little bit hard for you to see, but 1, 2, 3 is right there. That's 3. Now, the slope is negative 3/4. So, slope is equal to negative 3/4, which is equal to how y changes over how x changes. The little triangle sign stands for changing. Changing. A little song for you there, free of charge. So what I'm going to do is I'm going to change x by 4, and y is going to change by negative 3. Now, you can also go 3 over negative 4, but I always put the negative sign up in the numerator because I like to move x positive left to right. So what I'm going to do is I'm going to go over 1, 2, 3, 4. And the moment I do that, y has got to drop by 3. 1, 2, 3. Boom. Now let me do that twice. I'm going to go 1, 2, 3, 4, down 1, 2, 3. Boom. 3 points, plenty for a line. 2 points is all you need for a line, but I'm going to graph 3, and we are here, and boom. That is how you graph a line given something in slope-intercept. I guess I should mention, you know, rise over run. Okay, that's cool, and use that. That's what you like. Okay, so I mean, I could very easily have gone down 3 and then over 4. The only reason I always move the x first, and I said this in the last video, but I'll just say it again briefly here, is that how functions work is that x is the input, right? And so you change the input and then the output changes. So when I'm graphing, I always change the x and then I see what happens to the output, which is the y. So that's how I do that. That's how I do that. You be you. You be you. That's what I say. You be you. I'm just giving you some advice, but you be you. All right, let's do one more. Let's throw some negative signs up in here. So let's go boom, boom. Oh, there we go. Let's make it equal to 16. All right, so it's up to you now. Hit pause. Hit pause. Try to graph it. Try to first put it in a slope-intercept form. Ask yourself, what's the slope and what's the y-intercept? Unpause. All right, here we go. So what I'm going to do is I need the x's over here, so you can just kind of pick them up and move them over there. That's fine. You can do that. Just remember, if you're going to put it on the other side of the equation, the sign changes. So it gives me 5x plus 16. Notice the 16 is still positive, and now I changed it from negative to positive. Now I got to divide everything by negative 4. Oh my God. Holy Toledo. Who would have thought such a thing? And we got 5 over negative 4x plus negative 4. So that's our slope. We can graph that. I'm just going to leave everything here. Now, I like to, like I just said, I usually would think of this slope as negative 5 over positive 4. So what I'm going to do is I'm going to start at negative 4. 1, 2, 3, 4. I'm going to put a dot. What am I going to do? I'm going to change my x and my y values. X is going to go up 4. Here we go. 1, 2, 3, 4. And y is going to go down 5. 1, 2, 3, 4, 5. That's it. Plus 4, minus 5. Put a straight line and call it a day. Call it a day. I do want to quickly, if you will, mention that you can do this with kind of more traditional symbol manipulation. So you can go here, and this is the way I was taught when I was in school. Let me tell you about when I was in school. That's all. That was supposed to be funny. That's my old man impersonation. But actually, I've made enough videos now. I'm starting to think, man, maybe I ain't too far from it being a real thing there. All right, so you can add 5x because this is taking away 5 x's, right? 5 negative x's. So if you add 5 positive x's, you get to 0. Now you got to do that to both sides. So now we get minus 4y is equal to 16 plus 5x. Right, I'm just redoing what I just did, but a slightly different way. Now these aren't like terms, so they will not combine, but I am going to flip them around so the x's are in front. And at that point, you again, last step is always to divide by your y's. And you get your slope. And that's how the proverbial cookie crumbles. So let me relax you as we head on out of here today. Get you just a little bit more. There we go. Let's let that water flow. Oh, that's a beautiful thing. Ain't that relaxing? So, there is a little shortcut. Show you a little shortcut. Watch this. Watch this. There's a little bonus feature. This is like the B side of the track. Watch this. I'm just gonna take the AX and I'm gonna put it on the other side of the equation, so I get this. All right. Then I'm gonna divide by B, and this is a part where if you don't care about this, you can just end the video. It's cool, but you might think this is useful. And so it turns out that the slope is always the opposite of the A term divided by the B term. And so if this is, say, like 4x plus, I don't know, 7y is equal to 10, the slope is always the opposite of that term over that term. So it's always the opposite, it would be that would be the slope. This little shortcut. If that makes sense to you, good. If it doesn't, well, we're not there yet. Usually I always tell students, use a shortcut when it makes sense. If it doesn't make sense yet, then just don't do it yet. I hope I can convey to you my appreciation for your effort. It is Valentine's Day today, so I told my wife that I was gonna go home and do all the dishes before she got home. It's not the most romantic thing, but that's what I gotta do right now. I gotta make sure I get there before she does. So anyways, thank you for watching, and thank you for being a wonderful person. Cheers.